I was saying that
Recording in progress.
did you revise any of the things we discussed yesterday?
For bio?
No, for chemistry.
Yeah, but
Okay.
only.
Okay. Yes. So we were discussing about the atoms and elements
Yeah,
and
element. What's
yes,
our
yes,
compounds?
yes, and periodic table. In this periodic table, you
Mhm.
see this red zigzag line, this red line.
Yeah,
So
yes.
this is basically it is
It differs the
separating.
metals, yeah.
Yeah.
Non-metals and metal.
Yes, exactly. Which side is metal and which side is not metal? Like
Uh,
this is left side.
what's
This is
yeah,
left side.
it's
Is this metallic side or is this non-metallic? And this is right side.
this is the metallic, I think.
Left side or right side?
Yeah, left, I think.
Yeah, left side from here.
Metallic.
From the aluminum.
Yeah.
The boron is a
Yes.
non-metal. From this,
Yeah.
this whole is a metallic side. So you see there are so many metals. These all transition elements are metals. The group 1 and group 2, all the elements of the group 1 and group 2 are metals. Group 3 atoms are aluminum, gallium. These are metals. From here, germanium. From here, antimony. From this group, there is polonium. So these are metals and these are non-metals. Hydrogen is not in this category. We will see what is the category of hydrogen. Is hydrogen a metal or is it a non-metal or is it a metalloid? You know metalloids? Metalloids.
Mm,
Okay, there
I
is a
think
category.
so,
Yeah.
but like it's like
Mhm.
but it's like it between like metal and
Yes,
non-metals,
exactly.
yeah.
They have some properties of metals and some
Metals and some
properties
not
of
non-metals.
non-metals. That's why they are known as metalloids. So there are some elements we will see. Those are metalloids. Okay. Then we discussed how many elements are there in total.
Elements 118.
118. Yes. And naturally occurring among them are how many naturally occurring?
94.
Yes, 94 naturally occurring. And the leftover are the,
36.
yes, those are synthesized. And why some of the synthesized elements just break down
Because
immediately?
yeah, to break down, yeah.
Why? Why they break down?
Uh, because you can't find it like normally, like you have to build it.
Yes, no, no, yeah, we are building it, we are making it, we are synthesizing it, but
Yeah.
what is happening? It is breaking down. Why is this so?
Mm.
Because that is not stable. That's why it
Yeah.
immediately breaks down into another element. Okay, the answer
Mm.
to this is that they are not stable. That's why they break down into some other element. Otherwise, if
Yeah.
that was stable, it would have naturally present. Okay, if any
Mm.
element scientists synthesize in the laboratory and that is a stable element, so it means that element would have been naturally present. Okay, because in nature, you see, in nature, these 94, they are present from thousands of years. They are present from many years. Because why they are present? Because they are stable. No matter what
Mm.
conditions are, what environmental conditions are, how harsh conditions are, these elements are present. Okay, why they are present? Because they are stable ones. So the scientists, when they synthesize some of the elements, among those synthesized elements are unstable. That's why they immediately break into other elements. There,
Mm.
I
Mm.
told you the concept that everything want to be in stability. Every person wants stability in his or her life, right? Similar is the case
Mm.
over here. Whatever element we have, whatever composite we have, whatever compound we have, those elements they combine for stability purpose. Okay, we will look into the next chapter how bonding occur and why bonding occur, why we say that there is water, why hydrogen is bonding with oxygen, why carbon is bonding with oxygen, why there is carbon have bonding with hydrogen to form methane. Okay, we will see this in the upcoming chapter. The
Mm.
answer to this is for the stability purpose. Okay, instead rather than remaining in the single form, it is much more beneficial to be in a bonded form. Okay, because
Yeah.
it gives this compound a stability. Okay, it gives it a
Mm.
stability. That's why the elements combine. Clear?
Mm.
For the stability
Yes.
purpose. Just like you see the people when they go from from any country to a different country, they share rooms with some other people, like those who have low wages over there. Why they do so? Because independent living is quite expensive. Like if someone is in UK or US, so it's much more difficult for them to hold on all the expenses by one particular individual. So what they do, they share rooms, they share things. So this gives them stability in life. Are you getting my point?
Yeah.
Just giving you a random life example so that you can relate that why stability is important. This is just a periodic table. I will just remember this thing that these all they don't present in this form. Naturally they are not present like this. They are always present in the bonded form. Like the hydrogen can be present in this form. You will never see hydrogen like this. It does not exist. It will always be present in a bonded form. Like the hydrogen will be bonded with hydrogen,
Mhm.
or hydrogen will be bonded with oxygen. Okay, to form water, or there are
Mhm.
many different compounds for hydrogen. Similarly, the sodium, you cannot see it in individual form, it will be present like this, NaCl, or with any other compound. Clear? NaCl, NaF. Only the group 8 elements, these helium, neon, argon, these are those elements we say these are the stable one in terms of that their octet is complete. The helium, we will look
Just
into
just
this.
give me 1 minute. Just give me 1 minute.
Okay. I was telling you about the group 8 element, the last group. Instead of this,
Recording in progress.
except this group, all other group elements, all other group, these group from the group 1 till group 7, all these will be present in the bonded form. Okay, they cannot present in the single form. Like this lithium, beryllium, the group number 3, group number 4, group 5, group 6, group 7. Okay, these all group elements, they cannot present in the individual form. You don't see this fluorine like this. It will always be present in a bonded form like AHF. It can form bond with hydrogen, right? Or we have HCl. This chlorine make bond with hydrogen. But when we talk about the group 8 element, this last group, okay, this is the group. This group is known as noble gases group. Okay, these are known as noble gases. You can write it on your book. These are noble gases, the group 8 elements. Remember, the special thing about this group is that all the elements of this group they exist as individual atoms. Okay, the helium, neon, argon, krypton, xenon, and radon. All these, all these. What I'm saying is that these all elements are present in the form of individual atoms. Okay, meaning that they don't need to form bond. They are stable enough. They are stable in the single form. They don't need to bond. You see, the people who are rich, they don't need to think about anything. They can buy and they can live independently. But the people who are struggling in their life and they have to fulfill some family responsibilities and on the same time they are studying. So they used to share flats. They used to share grocery with some other person as well for the stability purpose.
Mhm.
But if there is a group of people, there are many people who are millionaires, who are billionaires, or even upper middle class families. They don't need to make groups. They don't need to cooperate with others. They can independently support themselves, right? They don't need to
Yeah.
collaborate with any other person to share flat or to share the grocery bills or to share electricity bills. So similar is the case over here. The noble gases, they are rich enough. Okay, they are rich enough. They are present in the form of individual atoms. They don't need to form bonds. And why is this so? The reason is that their outermost shell is filled. Okay, their outermost shell is filled with electrons. Clear? Are you clear with
Yes.
this?
Yes. Yes.
The which group I'm talking about? I'm talking about the group 8. Okay, this group 8 elements, these are known as noble gas group. And what are the elements in this? Can you name them? What are these? Can you hear me? Rohan, can you hear me?
Yes.
Okay, now can you name these elements of the group 8, the noble gases? Can you tell me the names of the elements in this group?
Hello. Helium and He, neon Ne, argon Ar, krypton
Just the
Kr,
names.
uh,
I'm not asking about their symbols.
xenon
Just tell me
Xe.
the, yeah, xenon. This is xenon. Okay.
Okay, okay, okay. Radon. Okay, it
Yes,
is xenon.
radon. Tell this radon. Don't need to look into the
Oxygen.
last. Yeah, it is not needed at this level. You just
Okay.
need to know about till this. Okay, till this. This is enough. Okay. So, are you clear with this noble gases concept that how we have many groups, but not all group elements can present individually? Only the noble gases can present in the individual form. And the reason behind this is that they have their outermost shell is filled with electrons. They
Yes.
don't need to share electrons for stability purpose. They are stable enough to live independently. Clear? That's why they are present in the individual atomic forms. Clear?
Yes.
Okay.
Yes.
Now, yes, we look into the groups. There are total 8 groups, and how we write these groups in the Roman numbers, right? The group one, group two, group till group 8. Clear? And I told you to memorize these names if you can, because it is
Yes.
important. This I will send you mnemonics of this. For any English mnemonics, you can memorize it. Okay.
Oh,
Then now let's talk about the periods. What are groups? Groups are they are vertical like this, right? This is group 1, this is group 2. Groups start from top to
yes.
bottom. Okay, the groups start from top to bottom. And why we have groups? On the basis of on which basis we make groups? Hmm. On which basis we make group?
Metals are metals are
Sorry,
metals and non-metals.
no, it's not true. If that's the case, why we have this?
From
This is
acidic
a
to
non-metal and this is a metal. Over here we have two non-metals and there is metal.
from acidic to non-acidic.
No, I told you that how on which basis you make friends in school? On which basis you make friends?
Oh, how similar are
Yeah,
like how
when you have
similar?
yes. Mm-hmm. On the basis of
Similar, similar.
some similarities. Just as for example, you have some friends in the school, like there are maybe there are 30 students in your class, but you do friendship with 2 or 3 just based on the similarities, right? So we have groups. These groups are what? These groups are known as vertical columns. Okay. These groups are known as vertical columns. You must write these things on your book. It will help you. Okay. These are vertical columns starting from top to bottom. Clear? Is my voice clear?
Yes.
Okay. Now, when we talk about the groups,
Yes, yes. Okay, yeah, kind of.
in the groups we say like the group 1 elements they all will have same number of valence electrons, same number of valence electrons. Okay, let me write it over the board. It will be Okay, over here. When we talk about the groups, we say that these are what? These are vertical columns. Okay, the first thing. Second thing is they start from
Hmm.
top and ends at bottom. Clear? Like, because these are vertical columns. The third thing is that they which property is similar, that in group 1 element, like for example if we talk about group 1 element, all the elements of group 1 will have same number of electrons in their valence shell. Are you getting my point? That if we talk about group 1 elements, there will be one electron in their valence shell. If I talk about group 2, there will be two electrons in their valence shell. We will see this in
Yeah.
detail. Right now, can you hear me?
Recording in progress.
Yeah.
Okay, let me change the internet. I think there is an internet issue. And yeah, okay. Is my screen visible?
Yeah, it's visible now.
Okay. The second thing I told you is that they start from top to bottom, and the third thing which I am telling you, that is the most important thing. This is the most important thing. Why we make groups? Because in the groups we place those elements which have same number of valence electrons. Okay, the elements residing in the same group, residing in the same group will have same number of valence electrons. Clear?
Yes.
Valence electron means the electrons in their outermost shell. In their outermost shell. So on this basis we make groups. For example, we talk about the group. I am writing over here. You will be clear by this. This is group one, lithium. Then we have heme. Okay, we can take three examples. This is enough. What is the atomic number of lithium? You have periodic table in your book, right? Open that periodic table
Yeah.
and tell me
Okay.
the atomic number and mass number of the
Atomic and mass number of what?
lithium.
Lithium atomic is 3
Yes, 3. And what is
and mass number is 7.
11?
7.
Yes, this is 7. Now, sodium. What is sodium? Sodium is 11 and 23, right? It is 11.
Yeah.
Atomic number is 11 and that is
11 and
20. Yes. What is potassium?
yes.
That is 39
Uh,
and atomic mass is, yeah, that
Potassium
is
is what's it
19 and
called?
39. 19 and 39.
39.
Yes, 19
Yeah.
and 39. Now, we
And
will look into the electronic configuration. You have idea about electronic configuration?
no.
No? Okay. This is this is atomic number, right? This is, you know this, that in the bottom we write atomic number. In the bottom, whenever we have, like for example, you have this one. If I talk about lithium, right? What is this? This
Yes.
3 is the atomic number of lithium, right?
Yes.
Atomic number, or it is also known as proton number. And what is this? This 7. This is mass number. Okay? This is mass number, or you can say
Mm.
atomic mass,
Yeah.
right? How
Yes.
how the mass number is formed? By adding proton number and what we add?
Mass atomic and proton number.
No, atomic number is same. The proton number. That is
The
proton number.
mass number and the atomic numbers.
No. Mass number is what? It is the number of protons plus number of neutrons. Okay, number of neutrons.
Mhm.
You add number of neutrons. And how many protons we have? If you see this example, for example, this is mass number, right? This is 7 is the mass number, and the proton number is 3. How many neutrons will be there? 7 minus 3, these are 4, right? Are you clear with this? What I'm doing? That I'm saying the mass number of lithium is what? 7, right?
Yeah.
So you will write 7, and then you will subtract proton number from it. So what you will get? You will get number of neutrons, right? Are you clear how we calculate the neutrons number from this? Let's take another example. For
Yes.
example, you have sodium. You have this sodium. This is 11 and 23. Now, 11 is what? It is proton number, right? It is proton number, and 23 is mass number, right? How can you calculate the number of neutrons? How many neutrons are in it? Simply,
33 minus 11.
yes, simply
23 minus.
mass number minus proton number. That will be 12, right? So in it there are
Yes.
12 neutrons. Clear? So
Yes.
now I hope you have idea about this now. Okay. One more thing, in an atom, the number of protons in a neutral atom, this is a neutral atom. Neutral means there is no charge over it. There is no charge. It is simple. In a neutral atom, the number of protons and number of neutrons is always same. In a neutral atom, not neutron, the number of electrons. In a neutral atom means there is no charge. No charge on it. Okay, I am writing in bracket. In a neutral atom, number of protons is always equal to number of electrons, right? Are you clear with this? What I have
Yes.
written.
Yes.
For example, in this lithium, we have proton number 3. The proton number is 3. So can you tell me what will be the electron number in it?
Proton number is 3,
3.
so
Yes. Electron number.
that will,
Read this.
if
Read
it's
this.
new,
Yeah, this
so
is
it
a
will
neutral
be,
atom.
yeah, so it will be 3.
Yeah, it will be 3. Okay. Similarly for sodium, what is proton number?
Sodium is the proton number
You
11.
see here, what is proton number? Yeah, 11.
Uh, uh,
Okay. What will be electron number?
electron number would be 11.
Yes. This is what we are doing over here, right? Now look into
Yes.
this. Now we will do electronic configuration. Electronic configuration is simply we have many shells. We have many shells in which the electrons are residing. Okay. Have you seen any atom? Any picture of any atom like this
Yes. Yes.
picture, like this? Okay. So we have different shells. Different shells. You have idea about shells? These shells, the
Yes.
shell number 1, shell number 2. So in these shells, electron move. In the center, what is there? In the center, there is proton and there are neutrons. Whatever the atom we have, whatever the type of atom we have, in the center, there will always be. Okay, let me draw this. Okay, if we see this, these are not the same, but we can consider in the center. This is a nucleus. Okay, this is a nucleus, and I told you in nucleus what we have. Always in the nucleus there will be protons and
And
neutrons.
neutrons.
Okay, and the electrons will be in these shells. Okay, in these shells. In this, in the first shell, you will always have 2 electrons. It is the full capacity. Okay, Are you clear till this?
Yes.
Okay. Then we have second shell, that is the in the second shell, that is known as K shell. This first shell. This first shell is known as K shell. This is very important concept, and it will, if you learn this right now, it will help you in the in all the inorganic part. Okay. In K shell, the maximum limit is 2 electrons. Like for example, you have a small room, and in that small room, only 5 people can adjust at one time for 1 hour or for 2 hours, right? Similar is the case over here. Whatever the atom you have, whatever the element you have, in the first shell there will be only 2 electrons. Okay, only 2 electrons.
Go.
Now look into the second shell. In the second shell, there is the capacity of 8 electrons. Okay, it has the capacity to fulfill 8 electrons. Clear? Just like if you see this, this example over here, you see 1, 2, 3, 4, 5, 6, 7, 8. Okay, this is the maximum capacity of second shell. We are drawing it for the sodium. Okay, we are drawing it for sodium. How many electrons are there? In sodium, there are 11 electrons, right? We are making it for
Yes.
sodium. Let me write it over here, 11 and 23. What I am doing is that I am drawing electrons. Okay, this is the method we use to draw the electrons. Okay, now second shell, how many electrons I told you? 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so in the second shell, the maximum capacity is of the second shell has a maximum capacity of 8 electrons, and this shell is known as L shell. Okay, the name of this shell is L shell. Okay, these names are prescribed by the scientists. We cannot change them. These are universally called names. So it has a capacity of 8 electrons, right? Are you clear till this?
Yes.
Now can you tell
Yes.
me how many total electrons we have? See this picture. How many?
Total electrons into one.
No. In this, how many electrons we have drawn? These are two. In the first shell there are two. In the second shell
Yeah.
there are 8. So in total we have
Yeah.
10. We have drawn 10 electrons,
12.
right? Now, how many is required for sodium? How much electrons are in sodium?
Hmm?
How many electrons are present in the sodium? See this.
And sodium,
Hmm.
23.
No, these are proton number. This is proton number. Electrons.
11. 11.
11. Okay. So till
11.
now we have 10. So in this shell, only one electron will be there, right? So
Yeah.
this is the image of sodium. Okay. And this shell is known as KLM. This is known as M shell. Okay. The maximum capacity of this shell is to have almost I there was 132, 18, and yes, it has capacity of 18 electrons. So in this 18 electrons can be there. But since we have just 11 electrons, so we don't need to fill this hole. Are you getting this? That how much
Yeah.
this is for sodium. This is for sodium. That in the first shell there will always be 2 electrons. In the second shell, that is known as L shell, there will be 8 electrons. And in the M shell, the total capacity is 18 electron, but for sodium, we just need 1 electron in this shell. Clear?
Mhm.
Okay. So I was telling you about the groups. How we make groups groups are based on the how many number of valence electrons are there. Okay. Like for group 1, if we talk about the group 1, we say that in the group 1, the valence shell will be having 1 electron, right? The group 1 means 1 electron in the valence shell. Group 1, if we talk about the group 1 elements, all of them will have valence shell electron that will be 1. Valence shell mean outermost shell. Now you see, this is the outermost shell, right? This one is the outermost shell. How many electrons are there in this outermost shell? This is the outermost shell, right?
Yeah.
This one, M shell. How many electrons are
Oh,
there?
okay. So
How many I have drawn?
1.
One. So it means that sodium belongs to group 1. Are you clear with this? We
Mhm.
don't look into how many
Yes.
electrons we have, we just look into the valence shell. Okay, when we are making groups, we just look into the valence shell, how many electrons are there in the valence shell. So all the elements of the group 1, all the elements of this group, the group 1, their valence shell will have just one electron. Okay, their valence shell. I draw for the sodium. Now let's draw for the lithium. You will see the valence shell, the last shell of the lithium will also have just one electron. Okay, let's draw for the lithium. I know it will be difficult for you right now to understand it, but you will understand once we do more practice, inshallah. Okay, this is the central nucleus. Okay, for the lithium, I am drawing for lithium, and we have this lithium 3 and 7. Okay, now in the first shell, how many electrons can be there? Now, first tell me how many electrons are present in the lithium. See this. Whenever you are making this
Electron.
diagram, first thing is you see how many electrons are there in this lithium. How many electrons are there?
Electrons. What's
Hmm.
it called? 3.
It's three, right? It is three. So you need to draw three electrons, right? And in the first shell, how many
Yes.
electrons you can draw? In the first shell, how many electrons you can draw?
2. 2. 2.
Two. This is the maximum limit, right? So I draw two electrons in this first shell. And this shell is known as K shell, right? This shell is known as K shell. Its maximum limit is of two electrons. Okay, now we have two
Yes.
electrons. How many electrons are left for lithium? How many
Uh,
electrons is now needed
one more.
to complete this? Yeah, one more.
One.
So in the second shell, what is the second shell? Second shell is L shell, right? Second shell was L shell. So I will just have one electron in this shell. Okay, this is known as L shell, and there is one electron in it. So you see, this is outermost shell, right? This is outermost shell. In this diagram, this is the
Yes.
diagram of lithium. And how many electrons are there in this outermost shell?
1.
One. So the outermost shell has one electron. Similarly, if you see this sodium, which one is the outermost shell? This M shell, right?